my general advice to people is start with Postgres before you start with any of these specialized databases, whether that's a document database or any of those other. Start with Postgres. And if then you run into scaling issues or something else, go read the documentation because you're probably doing it not optimally.
Welcome to Fork Around and Find Out, the podcast about building, running, and maintaining software and systems. This is an ad spot, but because we don't have a sponsor that paid for this spot, I just want to take a moment to thank everyone who downloaded, listened, and shared these episodes with friends. Thank you especially to the people that rated the show on various podcatchers. We've been seeing the comments, we see the ratings, and we thank all of you. The podcast is already off to a great start. We've only put out a month of episodes, and it's already blown away all my expectations for how many downloads and people subscribing. If you want to reach these subscribers and you want to help this podcast to last long term, please consider sponsoring. You can find the sponsor packages at fafo.fm/sponsor, or you can send us an email at sponsor@fafo.fm. I know there's a lot of F's in that URL, but I promise you there's many, many more in the podcast itself. Thank you all for listening and keep that feedback coming. Welcome to Fork Around and Find Out. I am Justin Garrison. With me, as always, is Autumn Nash. And today on the episode, we have Steve Pousty, Principal Developer Advocate at Voxel 51. This episode is, you're going to learn about how to embed things in your head for vector databases or something like that. Because I saw Steve at All Things Open in 2024. I walked into your talk, Steve, about vectors, databases, and embeddings. And I had been asking every talk, what is a vector database? Why do I need it? And none of them gave me a good answer. And then you gave great descriptions of it. So I said, you need to come tell the rest of the people, because 2025, everyone learned they didn't have a vector database. And for some reason they needed one. And so I wanted to have you.
Do you know how many podcast guests he's asked that question? And
it's been a running joke. Yes.
Really? And they just they can't explain it well? Or?
Most of them can't. Yeah. They can't explain, at least to the dumbed down simpleness that you did for me, which was great.
This is because people don't care about pedagogy. That's what I have to say.
I love when people get excited about, like, Steve, you missed Steve's whole face. Like, he lit up and he was like, I'm ready. Call me in for vector database right here. Like, I got this.
This is exciting. Well, because I've also talked about it enough and I figured out let's start from things you know, which is pedagogy, to things you don't know, and make that bridge explicit so that you can ground yourself in what you do know. So
that's why I give talks and do stuff. That is my favorite moment working in tech, is when you take something and you like go down the rabbit hole and you finally get to the point where you understand it in a way that you can use an analogy to like either make it a real world thing or something that people will understand, but to explain a technically depth concept. That's like I love that light bulb moment. I live for it.
Before we go too deep down the rabbit hole, I want to do a little bit of housekeeping for the podcast, just for everyone listening in. FYI, we are going to be moving this podcast to a monthly cadence. We also are going to be editing the show ourselves, which means I don't have enough time to bleep out any words. So there might be a little more, hopefully the levels are still going to be fine. There might be a little more distractions, a lot more ums and likes possibly, but definitely some more things that would have been bleeped before. So if you're listening to this show with kids or in a public space that's you don't want that going on, then just FYI, probably this episode going forward might have some of that. And I'll try to warn some people for the next couple episodes in case you miss one. But I just want to put that out there because we have been for the last 3 months paying editors, which have done a fantastic job. It's just a lot of, we can't afford it. And we're moving the podcast a little bit more to make it sustainable.
So you mean everyone doesn't teach their kids like bad songs and NWA and just tell them to not say the bad words? No?
I just let them listen to it and I don't say anything at all. I mean, not NWA. That's not the kind of rap I like, but in other songs. I'm more of an old school East Coast guy. So
East Coast? You live on the West Coast, Steve.
Yo, I'm from fucking New York. Don't you give me that. Yo, I'm not here for that.
I mean, I am definitely a West Coast 90s like person, but we love you anyway, Steve.
Thanks. That's really nice. I mean, I like some West Coast, like Far Side, but that Far Side feels kind of like East Coast, though, right? Like it's not that same kind
How
of.
dare you? That's where you were gonna pick, and then you just. Oh.
What's wrong with Far Side?
Okay, Steve, do you drink coffee?
Generally, no. Is that a good or a
start
bad?
keeping track of this. I'm gonna just start keeping a hash over here on my wall.
I know we need a tally on who uses Mac and Linux. And who
Linux.
Drinks coffee?
Yes!
Linux.
But for your personal or
Linux.
the dev desktop?
Okay, so the only reason I run Windows is because I play a lot of video games. And so video games, I have a Steam Deck and I can run some of the games on there. But if you want to run like a AAA, like COD or something like that, I need a Windows machine. If I could beat Linux every day in and day out, Linux day in, day out.
Shout out to Bazite.
Yes.
The Linux distro, which I absolutely love it on my Steam Deck.
See, that's why I run like Linux on a dev desktop and use a Mac, because I like it when everything syncs together and I don't have to think about stuff in my personal life.
Well, so here's the problem for me with that, using Mac. Mac's my least favorite operating system, by the way, because it's close enough to Linux without being Linux that all my muscle memory is frustration.
That's what I love about it, though, because it gives me the continuity, but I can use all my like Unix commands, Linux commands on Unix.
Yeah, but it's Z shell and stuff. Like it's BSD. So no.
Yeah. Once you use sed, if you don't have GNU sed, you're done. Like it's just like as soon as I go to sed and on a Mac, I'm like, I'm out.
And you
I'm
think
installing
learning
Linux.
PowerShell's better than that?
Oh no, I don't do any of that kind of stuff.
I was gonna say, like, how would that be better? Like,
no. Well, let's be calm and clear here.
Steve was like, "Well, too far, too
fast." No, I mean I've played with PowerShell just a little bit, but like
Steve to be the like sound effects.
Sorry, I mean PowerShell. I mean kudos to Microsoft for at least moving off of DOS. So kudos to them for that. But I'm mostly a WS. If I need to do that kind of stuff on my Windows box, it's WSL.
Which is a way better Linux environment than a Mac is ever going to give you. And so it's just like,
okay, I don't want to be in this religious war. I'm clocking out. I'm just letting you know.
Justin just leads you into spicy, and Steve was not today, Satan. Not today.
I've been down this road before. Next, you guys are going to be like, what's your favorite IDE? And if you guys say anything, don't say it, because if you say anything other, if you say anything other than a JetBrains product, I'm hanging.
Okay, see, I'm glad. See, Justin, he has to be like the super special snowflake of IDEs, operating systems, and all of the things. And he doesn't drink coffee, and he has to have Dr. Pepper, which means next week we will be walking up and down the streets of California trying to find him Dr. Pepper.
I'll bring my own Dr. Pepper. It's fine.
You said that last time, and you did not bring enough Dr. Pepper.
That's true. It wasn't cold. That was the problem. Anyway, back to the topic at hand. I just use NeoVim.
So you're a sadist. Okay.
Mostly going. Because I do remote desktop. Like y'all
didn't see Steve's eyebrows. Like you just missed a gem. Steve's eyebrows, the judgment, and his eyebrows. Like
I have never given IntelliJ a fair chance. Like I tried VS Code for years.
Also, I'm really bitter that they got rid of Adam, and like Adam was like my favorite. Mm. And I'm going to bite my tongue on that one too.
Now I don't like either one of you. But the thing is with the thing with NeoVim. So look, here's the thing I'm going to say about like those command line people, like Vim Emacs people, which I don't want to even get into that religious.
Emacs different. That's a religion. Like that is joining a cult.
Okay, but the thing is, I get it. Like I've seen some of them. Like when I was working on OpenShift back in the day at Red Hat, like there was the lead engineer. He was just like, I have VI with all these mappings, and he was just like. And I was like, that looks miserable. I don't want to waste.
Oh my gosh, the sound effects are amazing.
Ever since I've been a kid. Come on, Legos.
Can Steve just be in the background of all our podcasts, and then like when someone says something, Steve will just drop in with the like sound effects? I love it so much.
Is that called Foley's? Are those Foley's? Or is that what those Foley's are?
Foley engineers, yeah.
Yeah. Thunder.
See, look, if tech doesn't work out, Steve can moonlight as like a Foley engineer.
Totally. So yeah, we could get stuck like this for a long time. I don't know if it's true, but from what I've already observed of my hosts, it seems like we might all three be somewhere on the ADHD spectrum.
Oh,
somewhere.
so deep.
And so bottom lining is kind of like and moving and jumping.
You didn't have to attack us like that, Steve. Like,
I'm attacked like that every day. I wasn't diagnosed until I was 52. Do you know how hard that is? We could talk about that for a while.
I mean, we're 9 minutes in, and this is our 8th topic. So
exactly. And none
I
of them
think
is, and it's not linear, right?
I
It's
think
like,
at this point, this is what's expected. Like, if we actually held a topic too long, I think they'd be disappointed.
we get bored.
I know I am the adult usually, so I am going to try to bring it back
Okay,
on
Brent,
topic
let's go
a little
back.
bit.
Let's go back. Let's go back.
Let's go a little bit back, because
Okay.
back to the topic of embeddings, vector databases, not IDE stuff.
I was gonna make an old man joke, but like you are the old man of the
I am.
podcast.
I'm the responsible one. I know.
You are.
Technically, though, I bet you I'm older, but let's go.
I'm sure it's fine, but we won't. Try to stay
We're going to
focused.
get stuck. Next thing is going to
Focused.
happen if we stay focused, because otherwise we're going to start talking dating advice and stuff like that, and we need to get to. Let's.
I
wait,
mean, we'll get there at some point. Like
We will. But so, like, in good ADHD fashion, that will be our reward. We will talk about vector databases, and when we get through that topic,
just
we're
called us out
allowed.
so hard, and he's not wrong.
We'll get to talk about other things. Okay, let's set a timer.
Even
my
before we started recording, Steve hinted that he had some parenting advice, which we're going to leave that for the end. Like, we got to stick through this whole thing.
He didn't tell us. Like, it was
know.
like when someone's like, "Hey, I got something really important to tell you," and then they're like, "I'll tell you later," and then you just.
Did you just Pomodoro us?
He did.
It's not even a tomato or
I'm
anything.
trying to set a 15-minute timer. Is that
Y'all,
15? I think that's-
Justin.
15
Adulting
minutes.
of the podcast has been taken over by Steve.
All right, here
My
we go.
Steve's
Steve is
timer.
the adult.
For the next, oh crap! They went to the wrong one. Okay, there. 15 minutes. We got 15 minutes. We have to talk about vector databases and vectors for the next 15 minutes.
Let's start with embeddings.
Okay.
Describe an embedding.
Okay. And we have to start with embeddings, otherwise vector databases don't make any sense. Okay. So the idea behind an embedding is there's two types of data that you put on your computer: structured and unstructured. Right? Structured data is something like a database table, an Excel spreadsheet. It's really easy, and it's like all numbers and little strings and stuff. So it's really easy for the computer to say, "Oh, I know what to do with this. I know what to do." Is 2 bigger than 3? Yes. No. It's wrong. But 3 is bigger than 2. But it can. That's a bad.
That's what the AI would say.
That's
so
right,
it's fine.
exactly, because it can't tell numbers. But the point being that in normal space, in normal computing stuff we do, it's all small stuff that's structured. Like the computer knows what to do with it inherently at a certain level. I know I'm fudging that. But unstructured data is things which doesn't actually have that kind of, this is an integer. This is 16 characters. This is whatever that is. And there is no real easy way to represent that in a computer. So examples of this are photographs. Right, a photograph, yes, it's made up of numbers, but there's no way that you can just look at them. If I just showed you the matrix, which was the number for each of the pixels, you can't look at that and go, "Oh yeah, I know exactly what that's showing me." And there's nothing a computer can do with images. Like if you say, "Is this kitten picture cuter than this kitten picture?" Right? It can't answer that question. It has no way of. There's no semantics around that because it's unstructured. It can say, "Is this image the exact same or very similar?" But other than that, computers don't know what to do with the rest of it. And other examples of this, I'm going to be talking a lot about vision, probably mostly around this stuff, just because that's what I do now for my day job. But this is the exact same thing we do with all the AI stuff, what people call LLM stuff, right? So a book, right? What is the general theme of this book? A computer can't tell you that inherently.
Can you give us a general overview of what you do currently, just so we have the context, whatever you can talk about?
I can talk about everything. I'm a developer advocate. So I work at Voxel 51. And so Voxel 51 it was started by a bunch of computer vision scientists who are like, we need this platform to do this. Oh, hey, a bunch of other people really need this platform to do this. Because working for all of these models, all this computer AI stuff, even if you've taken any statistics, you understand that the data is the most important thing. Right? Like if you have messy data, if your data is not clean, it doesn't matter how fancy your model gets, it's still going to basically produce garbage. And so what Voxel 51 is this piece is like you pick a sensor and you pick a question, like what's your question that you want to ask? And then we kind of bind together the whole process of tuning your data, cleaning your data, making sure it's okay, annotating your data, like all the pieces in between. And then once you've training your model, fine tuning your model, and then you put it into production, right? And then we don't help put it into production, but then we'll help monitor it as it comes out of production. Like what is the class of all these errors we keep getting with our vision model and stuff like that. And so my job as a developer advocate is to be a bridge, right? So I'm the bridge to help you understand what Voxel does, which hopefully I did an okay job right there, and then go out into the world and help people understand that and understand computer vision more. Rising tide lifts all boats. But then also, like when I teach a workshop or when I will talk to Justin at All Things Open and he says, hey, blah, 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 I tried 51 and da, 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 da. Then I come back and say to the engineers, hey, I talked to a bunch of people and they're having problems with this, or I hear a lot of people are doing this. We should really think about putting this into our product. We have an open source project and then we have an enterprise product. So that's what I do. And then I'm also like a bridge between sales and engineering and support. Like we advocates generally are bridges between lots of different groups, and that's what we do. So does that make sense? Did I give it a good explanation for that? Okay.
Yeah.
You can do embeddings for all sorts of unstructured things, like big text, lots of text, PDF document, a book, several paragraphs even. Like for most of us who've worked with computers, we did that exercise of like comparing two strings, right? That's pretty easy. But other than saying this 3 paragraphs is exactly the same, or here's all the characters that are different, there's not much you can do that has meaning with it in the same way you can say is 2 bigger than less than 3. I got it right that time. So videos, audio, all these things that are generally big and we as our brains can process is super easy to process, but computers don't have an inherent way to process them. So that's unstructured data, right? And so for a long time, there wasn't anything we could do with unstructured data. And then there were some simple things we could do. But what comes along are these neural networks, right? And so basically what an embedding is you take that unstructured data, you shove it into the neural network. It has already been trained to pick out, the word that they use is features. So important things. So things that, and another way of saying is things that have semantic information, right? That have like meaning. You'll hear the word semantics thrown around a lot, thrown a lot. And at the other side of it, it spits out a vector. Usually it's like 512, it could be up to 2000, it depends on what, but it's a vector of numbers, typically between -1 and +1, some sort of floats, but there's all sorts of other ways to do stuff with it. But what's encoded in that vector is the semantic meaning of that unstructured text. And one of the properties of these is that things that are more similar, unstructured things that are more similar, should in that 512 dimensional space be closer to each other.
So let me try to explain this back in a way that I'm trying to think about it. If I have a text file and I run it through SHA-256, I would get a string of letters and numbers out of it. And if I change one character in that text file, theoretically, I get a completely different SHA-256 out of it. Like that's a good hash is different no matter, with small changes. And in this case, we want like the opposite of that is like I change one character or one word in that text file, and I want something that looks kind of like the thing that came out before. That would be, I could like, oh, you know what? Like 80% of this is the same, right? Like that hash is, and so this vector is just a series of 512 numbers or more or less, but generally 512 numbers between 0 and 1. And then that's our quote unquote hash in this example. And I can say, oh, look, like, 30% of those are pretty close. So that's probably similar to this other thing that has a similar characteristics.
In a very broad sense, that's exactly what it is, right? I mean, one of the things you should be aware of is embeddings, calculating embeddings. That's what they call these vectors, they call them embeddings. It is a compression technique. It's a lossy compression technique, right? I've taken a big chunk of text and converted it into 512 numbers, and it's lossy because I can't go exactly back from that vector to the original text. I remember in the early days, people were using hashes as vector embeddings, right? Like they would just say, I'm going to hash it, and that's a vector embedding. Some other examples of vector embeddings that people have come across are principal components analysis. I don't know if any of you did you guys any of you do stats?
No.
It's a statistical technique, like when you have tabular data, numbers and all that stuff, you do matrix manipulations, and then you basically end up with vectors where each vector is orthogonal, and the first vector captures the most variation in the data. The second vector captures like the second most variation in the data orthogonal to the first one and stuff like that. That's another way of creating an embedding, right? It's basically taking some data and then reducing the amount of numbers in it.
But the general idea of an embedding is just a way to almost fuzzy match something else that is similar.
But it turns out it's better than that, right? So it's not just for matching. So this is the important part. So first, let me explain why they're called embeddings. So the reason, because I just call them vectors, but the reason why some people in the machine learning community who need to rename everything that's already well known in the statistics community to some funky name, the reason why they call it embeddings is because, and this is related to that similarity, that embedding, that vector, represents the coordinates of that piece of unstructured information in a 512 dimensional space. So you're taking that unstructured information and embedding it into that 512 dimensional space.
So it's a point.
Yes, a point. It is the point coordinate in a 512 dimensional space, which no one can visualize, right? But
I can visualize 3 coordinates, right? And say, okay, if this was a 3 characteristic vector, I could say it goes in this point. And if I say a cat is this point, then a leopard might be a point close to it.
Yes. So, I mean, you can actually do that, right? There's no reason you have to spit out a 512 dimensional vector. You could just spit out a 2-dimensional vector if you wanted, right? And that would be like through the neural network, it would be looking for features and doing stuff. But then at the end, it would say, here's the X and here's the Y, and that's where it ends up. And so, yes, what should happening in that dimensional space, and if you want to just think in 2 or 3 dimensions, cat should end up near cats. And if you put in a picture of a dog, the picture of the dog should be farther away. And if I put in a picture of a motorcycle, that should be farther away from both, and somewhere else in that dimensional space.
How do vectors and graph databases relate?
So beyond my expertise, this is one thing you have to be good at as a dev advocate, saying, I don't really know, but I'll make stuff up.
I think everyone in technology should be good at that. That's real. That's so real.
It is, because a lot of damage could be avoided. Or at least say, I'm making this part up. I mean, I think something like that. So what I've seen, people actually care about graph databases in this space a lot as well, because one of the things that graph databases do is capture relationships between things. And so when you're looking at relationships between paragraphs and stuff like that, people want to kind of ground with a graphing database, because it actually had or you could say like this picture of this cat, this picture is the picture of the parent of that cat. Or you could say you can do stuff with it. Honestly, though, I haven't played as much with them. Neo4j does have an embedding extension, right? So it's obviously something different. It's just a way to take a piece of unstructured data and turn it into numbers. It's what it's trying to do is take an unstructured data and turn it into an array of numbers that captures the most amount of meaning from the original structure, the unstructured data, right? That's its goal.
I think one of the things I've learned about graph databases is just how bad they are at things that aren't explicitly put into the database, right? Like if I have rows in a SQL database or something, like I can't just like make up like, oh, what would be the customer between these two customers? Like it can't do that. It can't make up something in between. And graph databases are similar to that, where it's like, oh, we're going to capture all this information about the things you put in here, but we can't, if you give us something new, I can't tell you like what the relationships might be with those other things. And that's where it seems like vector databases and embeddings fill that gap. And that was my understanding. What it was like, oh, and actually, just go ahead and describe vector database and how they relate to that.
No, I can't yet, because there's a whole bunch of really fascinating things about embeddings that I really want to cover, because vector databases are interesting, but like embeddings are even more interesting. Embeddings, you can do algebra with embeddings. So this part is kind of really fascinating that you can do this. What you can do is you could say king minus woman, and it will return queen. Or you could say things like it knows that relationship through algebra. Like you can add and subtract embeddings and it will obey that relationship. I think I might have gotten that not exactly right, but I do know that you can do algebra like man is to woman as king is to queen. It knows that relationship, right? So that you can say things like king minus woman equals queen, or king plus woman equals queen, or something like that. I think it might be plus. So king plus woman equals queen.
Have you ever seen it get something really, really wrong?
So here's the thing, of course. I mean, the algebra could be, of course. The thing is, remember the part that was in the middle that makes the embedding? It's a neural network, right? And everybody, especially all the tech bros, want you to think these neural networks are actually thinking, and they're kind of like humans, and they're smart, and they have a soul, and they don't want to die. They're all really basically just really, really, really fancy regression equation. I mean, I think people really need to understand, and this is the part that I think is important. I mean, if you want to go a little bit more sophisticated, it's a whole bunch of nonlinear regression equations at each node in the neural network is what it's doing. So it's this big nonlinear system of equations, but it's still a statistical fitting to the data. So what people are calling hallucinations, now we're not out of embedding space, now we're into model and prediction space, but what they're calling hallucinations, they're not hallucinations. Hallucinations are what humans do. It's a model error. It mispredicted. That's all it did. It made an error in predicting. And they will always make errors in predicting because they're a statistical model. There's no way they can't. The way they're made, if anyone tells you that they can get rid of what they're calling hallucinations by using this technique or that technique, they're wrong and run, because We did 15 minutes. That was pretty good.
I'm so proud of us. But I think like that's kind of, I love that for one, you said, hey, I'm going to explain this, but I might get parts of it wrong and I don't know this. And then just to like, I think people think that we're against AI, and I use AI every day. I use it to make life easier all the time. But we can't keep selling these products and selling this thing for what it's not. It doesn't think, it doesn't have emotions. It's really fancy math and a bunch of like regression, like you said. You know what I mean? And if we just use it as for what it is and we understand that, then we know where to put it and how to use it and how to use it safely, you know? But I just don't get why we can't just use it and call it what it is. Like what is such a hard time with that?
Well, I can give you one reason why. One is copyright violation. We're all pretty sure that they're scraping copyrighted information and not reporting it. And the thing is, if they can make it portrayed to be a human-like, and it's learning, then it's not violating copyright. Like there's nothing stopping, I'm not violating copyright if I read the Encyclopedia Britannica and then tell you information I learned from it because I've taken it in and consumed it and I've learned it. That's not a copyright violation. If I, though, say I'm quoting the Encyclopedia Britannica and I keep quoting it without referencing it, then it's a copyright violation, right?
Every 90s CD said the bands that influenced them, right? They're like, you read the like 5 different artists that like were the most influential. And if that wasn't a person, that would be copyrighted.
But here's what's wild to me. It would make it a more reliable source and it would be easier to use, right? Like, okay, so when we were all in college and high school, we had to quote our sources, right? If it gave us an answer and then said, I got it from this source, like we figured out how to move the times in multiple other areas. Before, people used to sell CDs and they used to get money in a certain way. Then they had to figure out how to make money off of like iTunes, and you know what I mean? At what point do you figure out how to pay a little bit back? But you're establishing the trust of knowing, like, and then let's say it says, hey, I think you mean this. I got it from this source. It would help us to trust those models and use them in a better way because it's citing its sources. And then it would also help our kids and just the future and everyone that's using these to know where it's going. Like, it's just wild to me. This is like $1 billion industry. We're willing to sink so much money into it, and you could almost legitimize it, but they're like, no.
No,
Like,
because if they legitimize it, they won't get the valuation. One is copyright. The other, I think, is they won't get the valuations they get. Right? They keep wanting to say that we've got AGI, and we're not even close to AGI. Right?
If you make something understandable, then it was like, oh, I can't dream what it might be. It's like, oh no, I understand how that works now. I don't really.
It's
care.
wild how much of the black box magic that tech just, you know, like it's like back when they had to like, like remember when like people thought the cloud was magic and like
to the cloud.
Yeah, and people had to start going around and making the shirts that said, "Bro, it's just somebody's like Linux server." You know,
the cloud is somebody else's server.
Yeah,
right.
So much of it is like
yes.
You'll hear people talk about this new cool thing, and you're like, "That's the same thing we've been doing with this, guys."
It's just someone else's. I don't have to manage the servers anymore. I mean, so I'm violently agreeing with you, and I don't think it's going to change, unfortunately. And I know we're supposed to be talking about embeddings, but everybody gets to this eventually as well. Do you want me to explain what an LLM is doing? Has someone explained that to you?
Not yet. I have 2 other questions.
Okay. Because I want to say it because
do that, because I really think I would love to contribute to educating people, because it like, you know what I mean? Like,
yes. The reason I want to do this is because for the exact reason you said, which is people then can understand why it's hallucinating or what it's doing, and then maybe we can work on tech to make it better. But that apart,
and then
you can just tell it people
where to use that tool. It is a tool. Let's use it. I'm for using it. Let's just not use it where we're going to hurt people and make dumb like implementations. Like,
2 questions. Have y'all played Infinite Craft?
I love that this was your question, that you stopped him from explaining an ML.
No, because this is exactly what he was saying, where you can do algebra with the embeddings, and that's literally what this
bring us back on
game
topic.
is.
Okay, Dad.
And so that is exactly what it is. Like, I'm gonna put it in the show notes.
What's fun about Justin though? Like, really, like he pretends like he's just like super funny and just says spicy takes, but underneath the spiciness in that beard, he was like a math major, and sometimes Justin has the most interesting random, I read these 3 books and I connected them. Like, his brain works like a vector and graph database, and it's fire.
Well, and that's like So Infinite Craft, you haven't played it, is literally just doing algebra on the embeddings, and it's great because it does exactly that, where you're like woman plus, king is queen, right? And it's like you can do that math and you can try to like create everything. Really fun, but you're not allowed to play it right now on the podcast. You would not say another word. My kids played it for like 3 weekends straight. It was hilarious.
And it's called Infinite Craft?
I will send the link, but not right now.
Okay,
not
no, I just want to know the name to Google it later.
Yeah.
Okay, go ahead.
I want it so my kids will be busy for 3 weeks, but keep going.
The nodes and how things become, how a feature becomes a number, basically. Here's my thinking of it. How I think about it in my head is we basically take a picture of a cat and we chop it up into all the features that we think, and we put it in like you remember the Plinko machines from, where like the ball, the token falls all the pins. And I kind of think of all the nodes as those pins that like put it one way or another. And in my like the way I visualize it is a weight is just making that pin slanted one way or another, right? It bends it to one side or another. Say, hey, this should be weighted a certain way. I want this thing to fall a certain way more often than not. And in my head, that's how I kind of visualize it as, okay, a node is all these little nails on a board, and the weights are just, sometimes we just block off entire pieces. We're like, we are weighting out this thing and you're not allowed to do that. But also when we use the model, we don't hit all the pins. Like we're only hitting certain pins for certain features. So we cut up the picture of the cat into 200 little tokens, and we're only sending it down parts of the board to get a certain thing out. How wrong am I? And do you have a different way of describing nodes to people? When you're driving down the freeway and you see one of those billboards that say your ad here, this is basically the audio version of that billboard. This is Justin Still. We are still looking for sponsors for this podcast. We are having a great time learning with everyone in the community about how infrastructure works, how people are adapting to problems, and even looking for solutions that solve some of those problems. We don't do pay-to-play episodes, but we do love to promote people in the ad spots so other people can learn about what you're doing. If you are a sponsor and you're looking to reach this audience of developers and engineers, go to fafo.fm/sponsor and check out our packages.
Yeah, I don't have a specific way, but I can add a little bit more flavor on that. I don't think you're necessarily wrong, right? I mean, that's a good way of thinking about it, about you sent in this group of pixels, where is it going to end up when it comes out, right? At least in vision models, it's a little bit easier because we can actually look at what when you activate the different neurons, you can see what comes up. As you're moving up layers in the neural network for a fully connected neural network, you're building higher level features. So like if you look at the first level of a computer vision neural network, it's like finding straight lines or maybe a gradient or things like that, right? And then what happens at the next level is it combines some of those different neurons together to form, let's say, a curve, right? Because that's a curve that has colors going through it or something. And as you keep going up, you start getting things like noses. And then actually what you'll start getting is some of those nodes, like a nose and a couple eyes, will combine. And then now you've gotten a face feature, right? And so towards the end, you're getting very close to the things that you want to actually get out of the model in the end.
And that's the big difference between deep networks and wide networks, right? Because like a wide network is just going to be like straight lines at different angles. It can't really do the abstractions necessarily. You have to categorize every possible thing that you want to become an embedding, versus a deep neural network where like I can build 8 straight lines to make a triangle in a different shape in a nose or something, right?
Yes. And I'm not an expert on that deep level stuff, just to let you know. But everything I also do know about talking to those people who are at that level is it's kind of magical in the sense, right? It's black box. Oh, so this is another topic we should talk about. There's 2 reasons why you build mathematical models or statistical models. One is I want to actually understand what's happening. Like if I increase the temperature, what actually happens to that thing, right? So I don't care if I actually get the prediction exactly right. What I care most about is the relationship between temperature and the rate of reaction, right? I might not be able to predict most accurately, but I really know what it means to change the temperature, and I understand the mechanism. And then there's another type, which is prediction. Like I don't give a shit about what is going on under the hoods. I just want to know tomorrow, what's that stock price going to be? And should I put money into it or not? I don't care how you figure that out. Just I want you to be as accurate as possible with that stock price, right? And those are two different ways of modeling. And to be clear, all this stuff that we're talking about here is all black box. I don't care about the relationship underneath. I just want you to give me as accurate as a prediction as possible, right? So these models are not built for understanding what's the relationship between. It's just, if I give you this, get really accurate at giving me this, right? So that's important to understand. So I think that's part of why we don't know what's going on underneath the hoods, because they haven't been built to be the kind of model where you can figure out the relationship. They're just like, just get really good. And if I show you this face, is this the person I should let into the computer? Right. That's all they really want to be. I don't care if you got the nose angle exactly right, whatever you do, which can also be bad though. You want to hear a funny story about that with computer vision? I can tell Autumn loves funny stories. Yeah. She doesn't like to laugh, but she does like funny stories.
I do like to laugh. I think
Love
you're
it.
hilarious.
Autumn, you were laughing your ass off just 2 seconds ago. I'm kidding.
Okay,
Relax.
I was like,
what are you, like from California or something?
My laugh is so rude.
What are you, from California? We don't laugh. Sorry, that's a little bit aggressive, Stephen.
How dare you?
I'm just saying it was a good 10 to 12 years of cultural acclimation for me coming from the East Coast to the West Coast. I can talk about that later too.
Just because you guys are grouchy and we have tacos, leave us alone.
We have better pizza and we're more direct. Okay, so back to and bagels too. But you guys, but I'll give you tacos and sushi.
And
no,
beach,
tacos and sushi.
Our life.
Yeah, I'm with you on that. Okay.
You're going to tell us a funny story. You're going to tell us about how someone found out.
Oh, vision models. Thank you. God, yeah. All three of us together, we make one brain. The thing was, there were these people who were like, oh, let's see if we can tell dogs from wolves. Like, can we train a model that can actually say, this is a wolf, this is a dog? Because people are always like, oh, is that dog part wolf? Whatever reason, they wanted to do it. And they got this model, and it was awesome. Like, it predicted, like, with 99% accuracy on new data sets that, like, yes, this is a dog and this is a wolf. And how can this be? How can we have created such a great model? And then when they actually looked at your data, and this is tying back to data again, all the pictures of wolves had either snow or forest in the background, and very few of the dogs.
Up.
Yeah. So all the model had actually been trained on is if you see a forest or snow, yes. If you see a forest or snow, wolf. If you don't, yeah.
Exact same story. Someone was training a model on if something was cancerous or not. And it was literally health related. They were training this model and they kept getting it right. Like, this model is amazing. Exact same thing. They're like, oh, guess what? All of the pictures with a ruler in it were cancerous because they were the ones that were like in a doctor's office. It wasn't like someone just randomly taking a picture of something.
Right. We're like, now we actually need to know how big that tumor is. So we got to put a ruler in there.
Oh,
right?
look, this is how we decided. It wasn't the model.
And that's innocuous. Those examples are kind of innocuous about that. But this has also happened a bunch. Oh, we can talk about open source AI too. This is part of the important part about why any open source AI needs to include its data. There is something similar to that, I think, with health and race. I forget which races and which health item, but it was basically because one of the races had more disease in it than the other. If it knew it was that race or something like that, it would predict that person had the disease, even if they didn't have it, just because it had learned this is more likely to happen, so I'm going to weight more towards that because of the way the data set was unbalanced or something.
Just think about how that worked in like the mortgage scandal with Wells Fargo and several companies. You know what I mean? Like, and it's crazy because I argue all the time that like people try to put these fancy applications on top of bad data, and I'm like, how many examples do we need?
How many examples do but it's ongoing though. I mean, the Leon data set, this was a very famous, and they wanted, open data set, and they said it was great. And it turns out, because they had actually opened the data, some researchers had found there was a whole bunch of kiddie porn in it, right? Like there was like a whole bunch of because it was such a huge data set, there was no way for a human to actually go through and check it all. But it was like this large scraping, and the only reason we could tell that is because somebody could actually go and look at data. They said, but after that, they said we're closing the data, but we fixed it, and so now there's no way to know. And so the thing is, this was a huge debate in the open source community and in the AI community. What does it mean to be open source AI?
I've been also doing a lot of research on that because I'm writing a talk about security and how to make your code secure, and like writing open source like repositories and how to keep them secure. And it's so interesting that like you would think that, like most enterprise companies are like, it has to be, all of our code has to be like behind closed doors and we don't want anyone to look at it. But there's also so much evidence showing that a lot of open source problems have been found because the data is open. So it's like a really interesting balance of what you want to be seen in public with open source and what not.
Let me just want to say one thing on this though. just one thing. I won't go deep into it. I just don't think everybody needs to be open source, though. Like, I love open source, and I'm huge on. I've
Some
been doing
products should definitely not be open source.
and some data sets should not be open source, right? Like, if your data set was using proprietary, like people's health information, and it was personally identifying for those people, please do not
Like
open
our
that.
government should
Yeah,
be open source
my God,
right
don't
now.
do it.
I couldn't help it.
Plus, this is being recorded. What are you thinking? But just don't call yourself open source, and that's fine. You want to open the weights up and give us the weights? Great.
Well, I mean,
We'd love that.
they're called OpenAI. Like, we have a problem.
Oh, that's a very basic problem with them in general. It's like them and Meta are the two worst. Meta keeps wanting to.
What they want. Do you want to be a nonprofit? Do you want to be open? Do you not?
They want profit.
They want it all.
Two
Okay.
recommendations. Anyone listening, read the book, The Alignment Problem. It was the best. Like, it had all the examples of everything wrong with like aligning your data with the outcomes you want. Fantastic book. And also go watch the movie, the Mitchells versus the Machines, 2001.
I love that movie.
Cartoon.
Oh my
Like,
gosh,
the whole
it's so
the whole problem
cute.
breaks down to like them trying to get a vision model that can detect a dog versus a muffin or whatever. Like, that's how they beat the. It was great. Go
Dude,
watch that.
That is the cutest movie. Like,
It was great. Netflix original.
I ignore my kids' movies like 90% of the time. If they turn that movie on, I'm like, move out of the way. Move. Where's the popcorn? Also, my favorite part is the tech bro gets kidnapped by his own robots, and it makes me so happy.
But Autumn, the fact that you just said that makes me think you're showing your kids the wrong movies. Do you not show them the whole Miyazaki series?
What's that?
What? Autumn, you're leaving the podcast right now. I'm sorry.
Are you guys?
My Neighbor Totoro.
You have cat headphones, and you have like
It's funny when I tease you guys, but I don't like it when you do it back to me.
Autumn, you have just
Don't give me the Steve eyebrows. Those are for Justin. Okay.
Autumn. What I will say, Autumn, is I'll say it in a positive way. Autumn, let me introduce you to this great new world that you and your kids can share. So we'll do it off podcast, but
Steve, your expressions are just they're top tier.
Not Princess Mononoke. Just FYI, don't start there.
How old are your
What is
kids?
the difference?
How old's your kids?
7, 5, and 11.
Okay, so the 11-year-old may be Princess Mononoke. Listen, Miyazaki's a Japanese animator, but he writes the most glorious movies ever. Like, the imagination, there's strong female character, which is important for your boys. Almost all of them have really strong female characters, even the leads as well. They're
I love this.
Yes, it's amazing. My suggestion is start with My Neighbor Totoro. All the kids will like that one, and your 5-year-old may not get freaked out. I started my kids a little too young on like Spirited Away and the others.
Spirited Away's a little, yeah. Totoro, Kiki's Delivery Service, fantastic. The best thing you need to know about Miyazaki is he had a quote about, they showed him AI generated animation, and his quote was, it was an insult to life itself.
I think this might be how artists actually finally get paid their worth, because AI is going to ruin art so bad that they're going to be like, now everything that someone makes for hand will pay a bunch of money for. Also, Justin, you did a great job because you just found Steve randomly with a vector talk. Like, you found all this personality in a vector talk?
I didn't know he was from New York though, and so it was a little unfortunate there. I couldn't get all wins, but we're getting.
Whoa!
We got 20-ish
but I think
minutes
the
left.
personality is because he came from New York, so we got, there you go.
Bing, bing. Oh, sound effect. Bing, bing, bing.
We accept you for who you are, Steve.
Thank
We
you.
accept you.
We're not just canceling people and firing them just because of.
We got roughly 20 minutes left.
All right. So look. So once you've calculated these embeddings, there's all sorts of cool things you can do. You can actually use these embeddings to replace your information. Like, people are now doing analysis just straight on embeddings, not the pictures themselves. Once they calculate the embedding, they throw the picture away and they do their analysis on the embedding because it's got all the relevant information out. Okay, so now we've done a whole bunch of these embeddings, and every picture if you send the picture through an embedding model, you'll always get the same numbers out. Same picture, same numbers always. And
As long as you don't change the model and don't change the picture.
As long as you don't change the model, you can put any picture you want, and all of those images will get mapped into that space, right? And so now you've got, let's say, 10,000 embeddings. You're like, what do I do with all these embeddings? Like I said before, embeddings that are closer in space should be more similar. And so what vector databases do is they allow you to take those embeddings, put them into a database, and then create an index so that you can quickly search who's close to this embedding that I just passed in. So, like, find a picture similar, or find text similar, or an abstract similar. take your unstructured thing in, put it through the exact same embedding model that you use to create your other embeddings, get the embedding that comes out, ask the database, hey, what embeddings are closest to this embedding? And it'll give you back, if you say, I want 5, it'll give you back the 5 closest things to that thing you fed in.
So basically, an embedding would be something good if you had data that you didn't want to keep and have to worry about securing, and it could be something, you know what I mean? Like, because then you wouldn't have to care or worry as much about like, hey, I have all this data and I don't want to be responsible for it. I don't want to pay the storage. Could you just keep the embeddings and use those?
There's a reason I'm not in the security field. I will say tentatively, yes, in the
I mean,
same
you'd
way
have to
that
secure the embeddings, but I wonder if that would be less to store
it's
and
the same
secure.
as, it's the same kind of thing though, right? Like it's any of those kinds of things where I can compress and then retain the essential information. I can't, it's not the exact, right? So I can't go back to saying, yes, this was exactly a picture of a cat, but I can say, this is a cat-like picture that was originally there. Yes, you could do that. It's a way to compress your data while retaining, as opposed to something like a hash, which doesn't have any semantic meaning in it, right? It's just a hash. This says compress the data, but retain a bunch of the stuff that's important to me, which we haven't gotten to this yet, but I want to get all the way through in vector embeddings. The model you use is actually important in terms of what actually comes out in the embedding vector as well, right? It's not like I can throw it into any model and I'm going to get the exact same kind of features to come out. It depends on how that model was trained. So when you pick an embedding model, you want to pick an embedding model that has both the architecture that you would want, but also was trained on data similar to the stuff you want to ask questions about. Right. So like if I trained a model on so a very famous data set is MNIST, image data set. It's those handwritten numbers, which I'm sure you've seen over and over again, right? So if I train a computer vision model on that, but I want to actually tell apples from oranges or good apples from apples that have rot on them, a model trained on that data set's not going to do really well, right? Because it never saw those things. It only saw handwritten numbers. So you really do have to pay attention to the model that you use when you create these embeddings, because you can create a whole bunch of embeddings, but they might not actually show what you want it to show, right? And you can put them all the way through, get similarities, but they may not actually be similar things because the model doesn't even know that was never trained to know that those were similar things. A lot of this stuff, if you're going to do it internally, is a lot of experimentation. Right. This isn't like writing code and did I get the right output? It's let's try to run some of these steps. Let's try this model. Let's see if we add this many more parameters. How much is it? If we use a bigger model, yes, it's more accurate, but it takes this much longer to run and we have to use this much GPU. And like there's all these things, there's all these trade-offs and things that you need to pay attention to. I'm giving you the simplified version of this whole thing just so you can get the framework. But
No, but that helps. And I also think that it's another example of when you need the education to use these things, right? Because it's effective. It sounds like it could be used to have new, more efficient ways to do these things, but you need this education to make sure you pick the right tools. So rad.
Yeah, because that's definitely one of the things you're going to need to pay attention to. Okay, so then you put them in the vector database. One of the reasons you want to put them in a vector database rather than just calculating them, and if you didn't have the vector database and you wanted to do that similarity query, you'd have to keep all your embeddings in memory, and then actually you can calculate it exactly, right? Using an exact thing, or you could build an index on top. Most databases, the nice two parts about them is they're low resource consumption, right? Compared to keeping everything in memory. And two, they have an index, right? So you don't have to brute force calculate the distance between everything all the time, which you can do, and that'll give you an exact search. Most of the vector searches that you do now in a database, I use Postgres because why not? Postgres, you should Postgres everything, just like you should use IntelliJ, you should use Postgres because you all know relational already. Probably you've used some sort of relational database. Postgres is open source; it's owned by a foundation, so nobody's going to be like, "Well, we closed source that. You guys are out of luck now." And then the third reason is there's a ton of plugins, and I'm like a big geospatial guy. That's actually my really deep background. And it's like the gold standard for geospatial analysis in a database is PostGIS, which is in there. But
Also, I feel like you want, when the database, you want performance. You want something that, like, there's a lot of good databases and you need to pick the right database for the tool. But relational databases are what we teach in school, first of all. I won't say non-relational because that's like a lie. NoSQL databases will you still have to learn the access patterns, which people don't know. So even though it might be the better database, they'll dump it in and not do the right things that they need to do. So if you have to make a choice that you need something that's slightly more NoSQL and not as much structure, but you want it to perform well, and like your team has like a relational database background, and the fact that you don't want a license pulled from underneath you, Postgres has so many
There's a
good
JSON
points.
data type.
Yeah, and then like not just that, but be real, half of the relational database have Postgres somewhere underneath them with a bunch of cool tuning and like an interface, which is why they're so expensive.
We can get on that whole thing, but my general advice to people is start with Postgres before you start with any of these specialized databases, whether that's a document database or any of those other. Start with Postgres. You might have noticed that engineers in general think they need the fastest, biggest, whatever server there's going to be, and then they get it purchased, and then they're using like 2% resource utilization the entire time. So start with Postgres. And if then you run into scaling issues or something else, go read the documentation because you're probably doing it not optimally. After you've done the documentation and tuned your database again, if you still can't get it to work, then look at something specialized. But just start with Postgres from the beginning. Okay, so back to the databases and the similarity search, right? So those are the reasons you want it in a database. Once you've done this, the important part with these kinds of searches is you're not doing an exact search. If most of your questions are exact questions, like how much money did we make last year, you don't want vector database for that, right? That's relational or one of
Yeah,
those
that's
other stuff.
analytics and relational, which
Yes.
again is like giving people the information to make the right tools for the job because they think it's a black box of magic. And I'm just like,
Right, exactly. So for this one, there's questions like what is like this thing, or what thing is close to this thing, or show me other things like this things, or clustering, or looking for anomalies. Right? It's not like looking for exact opposites or anything like that. You're looking for something that is not similar, like credit card transactions. You could do that. You could build an embedding around credit card transactions that was both like the picture of the receipt and all sorts of other things so that it comes up with some vector, I don't know. And you can say, look, show me the closest credit card transactions for this person to this new one. And if the distance between those is really far, you could be like, this is probably not one of their credit card transactions, right? And so that's what would happen with that. I think there's different ways to measure the distance as well. Just so you know, and then they have different properties to them. The one that most people use is cosine, so it just looks at the angles. It does really well because mathematical reasons. But you can also do things like Euclidean distance, even in 512 dimensional space. Like a Euclidean distance is like the hypotenuse of a triangle. X squared plus b squared. The square root of the hypotenuse is a squared plus b squared, right? That thing, like straight line distance. But you can do it in all sorts of space. There's also like some people call it Manhattan, some other people call it taxi distance, which is like if you had to drive around blocks, right, rather than straight lines. So those are those kind of. There's all
see,
sorts of
being a New
distance.
Yorker does make you funny.
Yeah, but I'm not from New York City, thank goodness.
Where
I
are you
don't like.
from?
I'm from Rockland County. Do you know where Westchester is? Like White Plains, that area. Like it's a commuting suburb, 45 minutes north of New York City.
But it's in New York, but it's just like a suburb of it.
Yes, and if you're from
Got
New
it.
York City, I'm from upstate. And if you're from upstate, I'm from New York City, right? It's like one of those places where our claim to fame of the town that I'm from is we were one of the places supposedly that they went to on Sex and the City.
Ooh, I've watched that show.
You did? Okay. So you remember Carrie had like the woodworker boyfriend?
Yeah.
Not Mr. Big, but the other one. I forget what his name was. The one who like had a dog and like they bricked down the apartment between them.
Oh,
and
yeah,
they were
yeah.
very- whatever his name was. Anyway, he had a cabin out.
He's my favorite.
Yeah, mine too. But he's from Northern Exposure too. He was in Northern
Was
Exposure.
he Aiden?
But Aiden, yes.
Yes.
So yes.
He was the only one that wasn't toxic and total garbage, but keep going.
Yes. So Aiden had a cabin in the woods. It was supposedly in the woods, like far out in the middle of nowhere. And Carrie goes to visit him and she calls up, I think Miranda or somebody, and is complaining, I had to go all the way to New Jersey to get a cup of coffee, blah, 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 blah. The name of the town was Suffern, which is where I'm from. So it's an easy play on words. I'm in Suffern. I'm suffering here in Suffern. But there was Starbucks all over the place, and it was anyway.
They're just lying out here in Sex and City. And also, like, maybe you had to go all the way out there because he was the only one that wasn't toxic and hot garbage. But okay, whatever.
And actually had a connection to nature and real things. Okay, anyway, I think we've covered what you use vector databases for in general. So their use case is generally around similarity, not exactness. And you're using it for things which are unstructured generally, right? One of the things you might have heard about a lot lately is this thing called creating a RAG system, retrieval augmented generation. That requires a vector database. What the idea between a RAG is.
Could you explain RAG versus, was it AG, was it AIG or A?
Agentic?
Yes, between the two.
Okay, so I'll just give you a quick on agentic because I haven't really worked on agentic systems that much. Agentic to me is a fancy, from what I've seen, is a fancy way we've written a set of microservices using LLMs is basically what it is. So when
It's
you
a
send
daemon. It's a daemon that runs a daemon that does AI stuff, and it's like,
yes,
oh, this.
you send in a request to the agentic system, which is probably going to have a specialized LLM that's going to say, oh, given that type of question, this is the kind of LLM you want to answer this. So it's going to send that query off to that other LLM. And if it's a multi-step problem, it'll say, okay, I'll get that answer first. It'll come back to that same agent again, and then it'll send it off to another agent, another microservice that handles the next part of the question, and then it reassembles the answer and sends it back. That's the general idea of agentic. Maybe there's something more exciting, but given the history of how people have bragged about stuff, I'm basically thinking it's mostly like a microservice architecture for connecting LLMs together. That's an agentic system, right? Something smart enough or has some logic to say, put these together and bring them back into a coherent whole. RAG is completely different. The other option to RAG is fine tuning one of your models, right? So fine tuning means I take somebody's model, like the llama model, and I chop off the last layer, or I open up the weights again, and then I give it my own data and I retune parts of the model to be more focused on my data, my questions, the stuff I'm. So, for example, Justin is going to build an IoT specific LLM. Is that all that stuff in the background for IoT, or is it more for woodshop?
It's all different things.
Okay.
Sure.
Justin is going to build
It's called ADHD hobbies.
Exactly.
It's a pegboard of stuff.
It's a pegboard of. This was January of 2023. This is where he's going to build a maker bot, like a maker LLM that answers all sorts of questions around makers, not just the general internet, right? And so what he would do is he'd have a whole bunch of question and answer and text pairings around maker stuff, like you take Maker Magazine and scan that and do some other stuff, scrape some maker sites specifically, and then open up the last couple layers of the model and retrain or do that same training process basically again, but with his new data. So the model gets all this really good information it learned early on in the earlier layers. We're leaving that kind of structure, like how sentences are put together or how what are features and images I care about. But the later layers are now getting tuned specifically to the questions and the data that he's giving it. And that's called a fine-tuned model. And that's pretty cool. And it's fun once you do it. What RAG is I don't have an ML machine learning staff really there at my company. I don't have that kind of hardware. But I want to see if I can take advantage of some of this stuff. And the problem with using something like OpenAI or Claude or any of these really large foundational models is they were trained on the whole internet, right? Or some huge corpus of text. So the example I really wanted to build that was perfect for RAG, one of my friends, when I was at VMware, started using OpenAI as a dungeon master. And so he would be like, we're doing this campaign.
See,
and
now
this,
these are the use cases that we need to use OpenAI for. Like, you know what I mean? It's not going to hurt anybody. It's not responsible for any crazy decisions, but we're going to be efficient and let humans live their best lives and spend more time doing fun stuff.
when you noticed when he was doing it, it kept forgetting things, and it also didn't know all the rules, right? So he had to keep saying that was close, but remember, kobolds will attack usually like this, and then their hit dice is like this, and then it would generate a random number and do stuff. But he had to keep; it wasn't really getting it, which is a perfect system for what RAG is. So what RAG it stands for Retrieval Augmented Generation. We were working on a demo, and I've actually calculated the embeddings. I actually had to get a job rather than doing consulting, and I actually had to get paid rather than just doing something that was fun. But so what I did is we found all the 5th edition D&D manuals in Markdown. And so what I did is I took all the manuals and created embeddings for every Markdown header section from the D&D manuals. Like we had the player's guide, the dungeon master's guide, a couple of the monster manuals, a couple of campaigns, and I made embeddings for all of them, right? And then I stuck those embeddings in a database. And so now what we can do is we can say, when the user says, hey, I open the door to da 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 da, before we send that to OpenAI, we intercept that query. We take that query, create an embedding for that query, then use that to query our database for information in all the guides that is similar to the query the user was asking. And now when we send that query on to OpenAI, we say, here's the original query. And then underneath it, we say something like, for context, and then we include the information that came from the database that was tied to we stored the original text along with the embeddings, and we include that original text now with the user's query. Now, when we send that to OpenAI says, "Oh, right, we're not talking about the whole internet. We're talking about this very specific stuff, and I'm going to focus my answer particular to, and I have more recent information. Like you're talking about kobolds, I maybe crawled a couple things on kobolds, but now you're giving me like paragraphs about kobolds, so I know more about kobolds to give my answer back to you."
So like embedding is like extra information kind of. Is it like a text file or like what, like just basically extra information to help kind of give it more context?
The embeddings used in this case is you have this database of really relevant information to the user's question that the OpenAI doesn't have either doesn't have access to, or is not really focused on. So you want to find the most relevant information in your database to help give more flavor to the user's query.
Okay, so does it then just use your database, or does it use your database and the whole internet, but just uses your database to enrich the data?
And now we get to what is an LLM actually doing. So this is why you need to understand what an LLM does, right? At its essence, and if you substitute time for position in a sentence, an LLM is an autoregressive time series model. This is the exact same thing. So what happens is you send in your query. So here's our query, right? It's this chunk of text over here. What we ask the model to do is to start predicting words. So I don't know how they come up with their first word. They've got some sort of magic thing where they come up with their first word, right? That's going to answer your question. But they come up one word at a time. They don't predict the whole sentence at once. That's why you see it scroll across sometimes. It takes that first word. Let's just put that first word in the. Let's just say for some reason it came up with the. I don't know how it did it, but it's got the. Then it says, okay, and it's time for me to predict the next word. I'm going to predict this next word based upon the word before, and also constrained by the stuff that you passed in, right? So when they trained the LLM, it learned all these relationships between words and how they appear in sentences and which words appear more often closer to each other and all that stuff. So what it's doing is it's saying, okay, given these words that you told me in your query and this word I predicted, I'm going to predict this is the likeliest next word. And then the next word is given these two words or just the word before or whatever, or the rest of the sentence, given what you passed in and those words, what is the next most likely word? And it just keeps doing that over and over again. It just keeps predicting words one at a time as it goes down a chain.
Can I ask a quick question?
Of course.
Why does it use the compute power or, space to predict the next word instead of just taking in all the information and then looking through whatever data to do it? Like, what is the purpose of the prediction instead of just taking it all in at once?
No, it's taken all these words in at once, the ones you passed in, and it's using those words plus the words that came before to constrain the probability of whatever the next word is going to be.
Oh,
And
so the next word of the output or the
yes,
input?
of the
Okay,
output.
The output. Got it.
Sorry. So it's going to be like the kobold, and then it's going to what's the next word that's going to come after kobold, given that this is the information, the question you asked me, and all the relationships I've learned in the word, and the first two words were the kobold. What's the next most likely word in that sentence? Does that make sense?
That does make sense. And it makes sense the way that it just constantly thinks as it spits out more information because it's predicting as it goes on. So that makes sense.
Right. So, and this is how the beauty of ADHD, we're going to tie this all back to stuff all the way from the beginning about the safety and what we should be able to do. The way it's implemented currently is what's causing the problem. Because the way that we use most of those models is we tell it doesn't matter how much confidence you have in that word. Your probability could be 0.1 that that's the right next word. I still want you to put it in there. You still have to make a complete sentence for me. I don't care what probability that a next word is. It could be 0.9 that you're really confident that that's the next word, or it could be 0.1. I have no idea, but this is the best I got. And so what ends up happening is that's how an error gets introduced, right? Like we force it to predict a low confidence word, or it knew it was a low confidence word. Statistically, it knew, but it still had to put something in. So it puts it in. Well, now we're going to predict the word after that.
Are there any models that don't force it to do that?
The programmers could when they go to output it. So when that's getting done, OpenAI used to have this really great example, and I can't for the life of me find it. And I wish everybody would just do it now. is they would color code the highlight each word given the probability that the model thought that was the right word. So the sentence would look like yellows and greens and reds based on the probability that the model thought that was the right word. So if we're looking, it's not exactly perfect for us, but if you see like a red in a sentence that seems kind of fishy to you, you could be like, oh, well, that's probably a low probability word. This sentence is probably
This
off.
totally goes back to what we were saying. They want it to be the magic box so bad, but that would give more trust and more. And like, I would pick and probably pay for a model that would tell me when it's unsure, tell me where it got it from, and what are the other possibilities, because then you have context. Like,
Yeah,
so
I don't think you're ever going to get it to tell you where it got it from. And I can explain that one in a second, but you can get this uncertainty. You can also, they have other, like if you play with some of the examples on
maybe
OpenAI,
not tell you where it got it from, but tell you if it's a reputable source, right? Like a
it
reputable
can't,
source into context.
it still can't get that for you because the only way you could get that is you could constrain the data that it was trained on to only be reputable, what you consider reputable sources.
I mean, I would still take that too, because like look at like I usually really agree with Mark Cuban on a lot of things. I think he's great, but he basically told all of Blue Sky a week or two ago that you don't need to go to college or learn things. You can just kind of use AI because AI knows so much, then you can do all these highly skilled jobs. And it's like,
You can do them poorly. You can do them wrong.
exactly. And I think AI can be a learning tool because sometimes when I'm tired of just reading and doing stuff, I use it to kind of almost play games with, to like ask questions and help me get started. Like, how would you phrase this? Or like how to make my ADHD brain sound a little bit more coherent. But I still have to go back, read it, make sure it's saying what I need it to say, and do all these things. And like, it's almost a disservice to the fact that this could help kids. It could help even kids with learning disabilities. It could help people like get more into things. It really could be an educational tool, but we're selling it as a Bible and not an education tool. You know what I mean? And like selling it as in you don't have to be educated is a lie. Selling it as this can be your new tool to get educated would be helpful. Like,
So I wrote 2 blog posts why I don't like the current LLMs. And then I wrote some on why I do like them, like what I'm excited about for them. And one of the things I'm excited about, and this is probably back again related to the ADHD stuff and all the neural stuff, but writing has always been hard for me. I think I probably have a writing disability. And to me, these LLMs are a writing calculator.
yes, that's exactly what I use it for because I have all these thoughts. So I put all the thoughts out there and then I'm like, how would you say this incoherently and like full? And then I go back, read it, add what I want because it always takes out stuff that's important. It doesn't have context. But it's like wild because we could give the kids or us or ADHD folks context to use these tools to help us to do things.
Just like a math calculator, right? Like
Exactly.
you have to learn math. You have to learn the basic operations. You can't get out of it. But we're not when you go to do advanced calculations, we're not going to penalize you from being able to do that advanced thing just because you can't do this early, like this, you have trouble actually physically in your brain doing these early things. It's the same thing. Like looking at a blank page for me and saying, write a full essay is sure guarantee of like terribleness.
Dude, I've been in like this email, like talk, total just paralysis for like 3 days. And I'm just like, I literally was like, tell me where you would start with this. And then wrote like a ton of, like, I got so much stuff done because I just needed to get the like blank page paralysis
Out of the way.
out of the way.
And even if it's completely wrong, you can at least look at it and be like, oh, they got this part wrong. And
Oh,
then
I
this thing
rewrote
is
so much stuff. I had to give it more context. I had to
exactly
teach it how to, like, but it was the point of I wasn't stuck for hours.
staring at a blank page and with like I can edit great.
Yeah, a lot of people are better editors than they are writers, and you can't express what it is that you want, but you know when it's not the right thing, and you can nudge it back the right way.
But it's also executive functioning of just getting started, and it seems like such a daunting task. And when you feel like, okay, I don't have to do too much more. I just need to add this in and make sure it didn't forget things, and then rewrite it.
But it's still my own ideas.
Exactly. I've never let it just write anything for me, but it's a great start. So I feel unstuck.
That's basically what an LLM is doing under the hoods, and that's why we could make them better, but we don't. We could start to do things like predict the whole sentence before you send it to me, and if there's more than like 3 words in there that are below point 1, just tell me you don't know.
Dude, I would pay so much for that. Like, you know what? It's wild that it could, like, you're telling me that we got these scores and everything and they're just sleeping on it. And, like, and they're all doing the same stuff and not differentiating themselves. And these are wild, clear ways they could differentiate themselves and take the market with hundreds of millions of dollars being dumped in. And they're like, no, it's good. We want to be the
because they
black
want to be
box.
the best. You see them fighting on those leaderboards over a 0.1 or like a 1% improvement or a 0.1% improvement or whatever. And it's like, that's like, little bits on the end of the pencil. The thing that I need is better features, and like, it's a whole, yeah, it's very tech bro typical is what I would say.
Before you drop, Steve, we have to hear your parental advice and the other things that we were talking about at the beginning of the show that you were going to give us. So
right, but there's one other thing I still want to say about the model. I want to explain to you why you'll never get, because I understand why you want sources, and I said that in my blog post. You can't get sources out of it. You took regression though, right? Like do you remember regression, right? So what comes out of the regression is an equation, y equals mx plus b, right? Like if I increase temperature by this much plus some error, I'm going to get this. I can't, what it has is like one of those equations under the hood. There's a big, huge equation under its hoods. And I can't go back and say, hey, if we're doing height versus weight, tell me exactly which height made you predict this weight. You can't do that with a regression model, and you can't do that with these models either. I can't go back and say, because all the words and relationships gets mixed up into like a large equation. And so you can't go back and say, which article specifically taught you this relationship to this word or whatever it is. You can't, it's just the nature of the beast. You can't. RAG can help some with that though, and things like that, because you can give it a source and say, please include these sources in the result, like that are like related to your stuff. Because
that's exactly what like the Bing search does, right? Like Bing search is doing that, where it's like it's going to fetch a bunch of searches that does a web search and then generates an answer based on that web search. And it's like, hey, these are all the sources that I use to generate this other answer. But then everyone has to use Bing, and that's just not.
And it's terrible.
So,
Bing is such a bad search engine. It's so. I mean, I want to keep wanting to.
What's your parenting advice?
Okay, so the dating advice, that was the one that you were first. You're like, why can't guys just be normal? Okay, so here's my advice. This is what I gave to my friend who, she had some anxiety issues and stuff, and she kept dating guys. Yeah, so they were all, most of the guys she was dating. And so what I said to her, like they didn't understand it, and they were like, why are you getting so upset and all this stuff? I said, listen, I'll call her Mary, even that's not her name. Mary, listen, if you can find a guy who's divorced with kids and you see his relationship is good with his kids, that's the kind of guy you want to be with.
That's literally what I look for. Do they exist? And then like, how do I, like, just where do they live? Do they hide under rocks? Like,
You have to look for nerdy ones.
No, those are mean to me. Those are mean to me.
Do they have kids though?
Yes, I refuse. They don't even like their kids. Bro.
Okay, so that was the point. What was the thing I said?
Okay, but they don't. The two don't go together.
Yes, they do. Oh.
You know what, Steve? You send me a list of your friends, okay?
It's hard. It's hard. It's hard to find. I'm just saying.
They don't exist. I have searched. I'm about to create a bot that's AI that does my dating. Okay, I really do have to run to go get the kids. But Steve, I will come back.
Okay, when you come back, I will. But just say, look, when you look at their dating profile and they say they have kids, look if they have pictures of themselves with their kids in their profile.
They just use that. It's like they're using a picture of a puppy.
I know, but it's better than just dating some guy. I mean, you could get lucky and find some guy who's never had kids.
We have to.
Okay.
We need to just look, Steve. I will be back in 10 minutes.
Thank you, Steve, so much for coming on. Thank you, everyone, for listening. And Steve, where can people find you online?
I'm the Steve Zero on Blue Sky. You can find me as the Steve Zero on GitHub. I am in multiple different Slack communities. I've worked in Kubernetes before, so I'm in the Kubernetes Slack. I'm in the Geospatial Slack. I'm in the Voxel 51 Discord. Where else and they can find me on Voxel 51.
We did put you in the Blue Sky starter pack for Fork Around and Find Out guests. So if you are looking for people can check it out there. So
I was also going to say you can find me on YouTube also, but I don't know if I'm the Steve Zero on YouTube. And some of these talks of the stuff we talked about today are actually, I have YouTube talks. I linked to the recorded talk.
Sweet. I will put that in the show notes too. Once we get that,
I'll send it to you so you can have it in the show notes.
Awesome.
Okay.
Thank you, everyone, for listening, and we will talk to you again soon.
Okay. Bye. Thanks.
Thank you for listening to this episode of Fork Around and Find Out. If you like this show, please consider sharing it with a friend, a coworker, a family member, or even an enemy. However we get the word out about this show helps it to become sustainable for the long term. If you want to sponsor this show, please go to fafo.fm/sponsor and reach out to us there about what you're interested in sponsoring and how we can help. We hope your systems stay available and your pagers stay quiet. We'll see you again next time.